So today I'm going to talk about polished concrete. Many times when we are actually going out in the market, we notice there's a lot of haze around what polished concrete is. You have great vendors giving you the entire process to you have some who suggest a very superficial process, and the clients always had to sort of learn this on the job by actually taking a shot with any one of the vendors they think is reasonable. So, and since we constantly face this, and this is a concern that I hear from many people, I've decided that I'll have a three-part video explaining what I understand polished concrete is based on my research. So the first part is going to be what is polished concrete. The second part is going to be what are the things that one must avoid and what one must be aware of to have high performing flows. And then finally, how do you achieve high quality polished concrete flows, and how can you specify the same in your projects? So in this video, we're going to go into what is actually polished concrete. So the first thing what we need to understand is polished concrete is a process. Okay, the process has four important steps. One is the initial grind, then the right densification, honing and polishing, and finally the sealant application. The fact that polished concrete is not just a finish, is not a shine on concrete, but an actual following of these four processes. Based on your final use case, you can change the intensity of each process, but these processes have to be followed for the system to perform. So that's the fundamental. The second fundamental what you need to understand is how the actual flow has to be. So since this whole process is working on the base on the concrete flow that's been laid, it is good to understand how the flow must ideally look. There are plenty of reasons why the flow will not be of that state, what we theoretically would draw and show, but understanding this will help us achieve closest to it at our actual job sites. So if you look at this image, you see how the cross-section view of the floor is. So you have on top, you have any coatings, then you have the concrete cream, then you have the small aggregates, the medium aggregates, and the large aggregates. So this actually is achieved when you lay the floor and then it's compacted well. So one of the primary important is your mix design, which should be a minimum of M25 compressive strength. You need to have a well compacted flow. So many times we hear projects wherein you have M25 or even M30, but then it's hand traveled and so on. So that will not give you the effect because the flow is not compacted. As I go a little further into this, I'll explain to you why. So let's get to the first step. The first step is a good initial grind. Now, what is a good initial grind actually? What are you trying to achieve with this? One is you need to achieve a good aggregate exposure. See, based on the final use case, the aggregate exposure has to be decided, and a good initial grind will ensure that the floor is ground, removed of all sorts of surface weaknesses, surface issues, you could say. So, for example, the images that I'm showing you is an automobile factory. Here, we have very high stress, traffic, and so they've decided for a full exposure of aggregates. There could be a software IT park using polished concrete in the flow, wherein you wouldn't want to go a full exposure, and you can still have a well-performing flow. So the idea is, you should understand that we are looking at when a floor is performing post finishing, what is the abrasive resistance, and the abrasive resistance of aggregates, which are largely granite based, are much more higher than cement. So the so when you have a full exposure, you're having the surface area, you have larger of aggregates and less of cement, and based on the kind of abrasion resistance you want to achieve, eventually you can decide the aggregate exposure. The second important step in the initial grind that you need to look at is ensuring that you look at all cracks, all pinholes, all grooves must be addressed at this stage. Because beyond this, what you do is you don't really work on rectifying the flow. This is the stage wherein you rectify. So it's really crucial that this stage is followed perfectly. So if you've seen the images, we are actually using an epoxy to fill even the micro pores. Depending on the actual cracks at site, actual pinholes, actual issues at site, you can use different fillers from repair mortars, which cure quickly to epoxy mass fillers. There are plenty of fillers. So a good contractor, a good service provider can advise you what is the right fillers to be used. The third step, what every uh, planner, space planner must understand is polished concrete does not give you a uniform look up till the edge. That is primarily because most of the times when we lay the flows of power floated and the excess slurry happens to settle onto the edges. So you have, like in these images, you will see that there'll be a much like these patches of dark grays coming up on the edge, and this is primarily because the cement slurry happens to settle in the edges a lot more. So if you are looking at a polished concrete floor, you should be aware that this is a limitation. So if you're looking at the polished concrete floor in in a space where aesthetics are very important, then you have to design your floor accordingly. Maybe have have a gap from the edges which can be fit in with another tile or something like that. So these three aspects of the initial grind is crucial, and ensuring that any contractor, any provider actually follows these initial grind processes is important for a well-performing flow. The second step is the right densification. So what is densifiers? Densifiers are calcium silicates that react with the free lime in the concrete and creates a fresh structure. So now, to react with the free lime, what is important is the concrete must first be cured well and must be let to hydrate well. So usually it's 28 days, but depending on how certain different mixes, the duration can reduce. This your concrete, the one who's designing your concrete can suggest that to you. Now, and second important, which is quite practical, is that the flow must be washed and let to dry before you apply the densifier. Because the densifier has to penetrate into the flow, into the substrate. If you have a lot of dust, a lot of slurry, a lot of leftover material from previous grinding steps, your densifier is not going to really go into the flow. So this is again very simple, but a very, very crucial step. The third most important step when you're using the right densifier is the dosage. Now, depending on various kinds of your manufacturer specification, the dosage varies. But what is important is how do we check the dosage? So usually we use simple tips like planning out an area with respect to a certain quantity of chemical, and like in this image, and we ensure that this much chemical is utilized in this area. So that has to be predetermined, and again this also ensures how your flows are finally performing. The application style, so here we are using lithium silicate densifier, so it's just sprayed with a regular low pressure sprayer and then applied so that it's evenly dispersed. Again, using different types of densifiers can ensure that the application style would vary. The third step is mechanically honing and polishing. Okay, so what we're trying to achieve for a well-performing flow is once you've removed all weaknesses, all impurities, all damages on the step on the flow with the initial grind, and then you've applied a densifier which reacts with the free lime, what you have is a hard and a fairly flat flow. But still, due to the initial grinds scratch patterns, there is actually the peaks and valleys on the flow are quite high. And this can have for other effects, like you probably have the flows getting dirty, you could have scuff marks, etc. So for the flow to perform well, you need to reduce the peak and valleys, and you have to reduce this mechanically so that the floor is actually close to being almost flat, and that is done with good honing and mechanical polishing. So if you see these images show you what kind of gloss levels you aim to achieve with just mechanical finishing. So once you do this, then comes the fourth step, which is a final step, application of a sealant. Now, based on the final use case and the kind of exposures you have, you can decide what sealants to use. But ideally, a sealant is just used to prevent any from staining penetrating into the floor. So it's just a superficial layer. Now what all of us should understand is there are many, the sealant by itself has a sheen to it. So you could just do densifying and then apply the sealant and get a sheen. And what a not so experienced evaluator would assume that that's a great flow, but you should understand that that is not a great flow because you are just working on the strength of the sealant. So when the traffic is actually put onto the floor, if the sealant is not able to sort of hold onto the traffic, your floor will again starts getting exposed, and you'll start, the flow will not perform well. So the sealant's purpose is to prevent penetrations, but not to give you a shine. The shine must be achieved mechanically. So when you follow these 4 steps, there's no way your polished concrete can fail. Now, based on the final use case, like it could be an automobile factory, to an IT park, to a supermarket, or to a school, the extent of your grinds, the extent of gloss levels you want, so the extent of mechanical polishing that you need can vary. And based on this, the cost can have an impact. But if anybody is promising you to not do these 4 steps, then that is not called polished concrete. Brings us to an end with our first video. What my aim is with the next is to go into more nuanced aspects as to certain limitations, certain benefits, what you should look out for, and then finally we'll close it with how you can actually specify quality polished concrete flows at your job sites. So thank you for your patience. I hope all of you are using the most of your times indoors. Stay safe, stay healthy. Thank you.